Hi students, good afternoon from PANCHNATH. So yesterday, means the lecture 9 and 10, we have started hybridization concept, which is very important, as I told you. Yesterday we have completed very importantly SP hybridization, one example C2H2, right? Next SP2 hybridization, taking example of boron trichloride as a main example, and another example C2H4, that is ethene, right? And then sp3 hybridization, mainly methane, I have explained you. Okay. Now, in this class, lastly, in sp3 hybridization, apart from bonding pair of electron, if there are lone pair of electron, how to decide the geometry? Okay, that is formation of ammonia and formation of water. Using once again same this hybridization concept. Let us see. But if they are not involved in bond formation, then they are called non-bonding electrons. Why means? After this, you are going to study next VS-EPR theory. That's why I am telling you. There are two types of electrons: bonding pair of electrons and non-bonding pair. Non-bonding pair of electrons are also called lone pair of electrons. Right? Bond pair, lone pair, unpaired. Totally different. Unpaired means only single. Ekangi, right? Pair, lone pair, okay? Lone pair which are not involved in chemical bond formation. Bond pair which will have capacity to take part in hybridization and chemical bond formation. Laser, right? Okay, now coming to formation of ammonia. We know that nitrogen is having atomic number 7. 1s2, 2s2, 2p3. That means in the valence shell, how many electrons are there for nitrogen in that? How many electrons are there for nitrogen? Valence electron must be valence. Apart from this, how many? 5. 2, 3, 4, 5. 5 valence electrons are there for water. That is nitrogen. Right? Okay. Now, these valence electrons are shared with the 3 hydrogen. As you know that hydrogen is having atomic number 1, it is having half filled 1s. 3 such hydrogen. That means nitrogen is having 5 valence electron. Out of 5 valence electron, 2 are paired, 3 are unpaired. These 3 unpaired electrons are shared. They are sharing with what? 3 hydrogen atoms. Not overlapping. I am telling you sharing, not overlapping. Right? So, see already this is paired one. This is called PP. See, it will share and will form 1s2, right? 2s2, right? And remember 2px2, 2p2, 2p. The question arises: where does these three electrons come from? 3 hydrogen. They share. Like they will form what? sp3 hybridization. Okay, yes, p3. But remember, yes, p3 hybridization. But this is bonding pair, which is already paired, and these are non-bonding. Sorry, this is LP, lone pair, and this is BP. This is BP. This is D. That means how many bonding pair are there here? 3 bonding pair, 1 bonding pair. Got it? Then what is the structure of nitrogen? Actually, 3, 4 plus 1, 3 sp. Actually, it should be sp3 tetrahedral geometry, right? So nitrogen can be written like this: 1, 2, 3, 4. Share with hydrogen, sigma bond. Share with hydrogen, sigma bond. Share with the hydrogen, sigma bond. And this is one lone pair. Okay? BP, and LP. Due to this, see, these will try to become as far as possible swell. How? By minimizing repulsion. How? By going away. All are electron pairs. These are bonding pair, this is lone pair. All are negatively charged. That's why they repel each other in such a way that so as to give definite geometry to the molecule. Right? So, this is actually value This is what we call as trigonal pyramidal. Actually, according to hybridization concept, see, if it is sp3, what could be the geometry? Definite geometrical shape? Tetrahedral. But it is not tetrahedral. Why? Due to this lone pair. They repel and there is a change in the geometrical shape. See, it is trigonal pyramidal. Like this, I have to explain using sp3. Okay, that is due to repulsion force between the electron pairs, bonding pair and lone pair. And instead of bond angles, it should 109 degree 28 minutes or 109.5 degree, but it is decreases. Here bond angle also distortion 107.5 degrees. Decreases by. Okay, so this is how we can explain formation of anything. Right? Like this, they will also understand water also. In water, central atom is oxygen. Oxygen is having atomic number 1s2, 2s2, 2p4, right? 1s2, 2s2, right? 2p4. 2p4 you can write 2px1, 2p1, 2pz1. This is 2px2, or you get 2p1, 2pz1, 2 unpaired. Now these unpaired 2p by 2pz, they will share with the 2 hydrogen, because there are 2 hydrogen atoms. One hydrogen you know, 1s1 half paired, they will share with this 2 hydrogen, 2 such hydrogen will share here and will form 1s2, 2s2 and 2p6. Make this 1s2, 2s2, already paired with this. In 2px also, 2px2 is already there. They are called in LP. Now remaining these two see. One of nitrogen, one of hydrogen. One of nitrogen, one of hydrogen. See, unpaired electrons with the opposite spin. These are called bonding pair of electrons. See. Here also, what is the hybridization? 1s and 3p. Right? Including lone pair and bond pair. Got it? To complete the object. So now there are 2 lone pairs and 2 bond pairs. Now put in the structure. Same oxygen you can draw here. Right? Okay, they will share here hydrogen, share hydrogen HCl. Okay. What about another 2? These are lone pair. Due to lone pair, they will arrange lines. Okay, and that's what is having band V-shaped structure of. Always I used to tell so many times. Okay, this is the lone pair, LP, and bond angle here decreases to 104 degree 5 minutes, and these are band or angular due to repulsion between lone pair and bond pair. That means as the lone pair increases, repulsive force increases. LP is greater than LP, BP, and VP is greater than BP and BP. Means as the number of lone pair of electron decreases, repulsive force decreases. Right? That's why see, this is one lone pair here, but here 2 lone pairs. Band V-shaped or band or angular, or we can also tell it as generally band V-shape. Band V-shape or angular in shape. Got it? Very, very important for CET. Karnataka CET, so many times this has been asked. Karnataka CET. 2 lone pair, 1 pair, 1 angle decreases to 104 degree 5 minutes by 2 degree. Here 1 lone pair decreases by 2 degree. Okay, 107.5. But actual geometry, if tetrahedral, it should be 109.5 degree. That means what you come to know from here, students? Lone pair will distort the geometry. Distort means disturbance. Not a regular geometry. It is irregular geometry. What is that irregular geometry? If it is one lone pair, from here it is trigonal. Instead of tetrahedral, it is trigonal. Here instead of tetrahedral, here also what it is? It is bent V or angular shape. Remember. This is called, that means it is disturbing regular geometry and even regular, not only regular geometry, even in bond angle also. Okay, so that only we are going to study next. This has been explained by very well without using the concept of hybridization. Okay, valence shell electron pair repulsion theory. Electron pair repulsion theory. No doubt, valence bond theory was given to explain about shape of molecule, especially regarding polyatomic molecules, because it was not explained by Lewis theory. Even Lewis theory does not answer about shape, but that only regarding shape, distortion in the geometry is explained by valence shell electron pair repulsion theory, VSEPR theory. That's why students, I not told you in the beginning this VSEPR theory. This VSEPR theory comes after valence bond theory and hybridization. Remember. Now you tell me in VSEPR theory what is the difference between geometry and shape. Geometry and shape. Regular geometry and shape. Distortion in the geometry, that's only nothing but shape. Okay. Geometry means what? Arrangement of atoms in three-dimensional region in a certain specified manner. Orientation in three-dimensional region in the space. It is geometry. But due to this LP repulsion, it is just have a stress and it has been stressed. That means it has lowered the bond angle. So bond angle will decrease. Why? Because there is a stress on the, what you call it as angle strain on the molecules. Okay. Due to lone pair, there is a repulsion. The molecule gets compressed. Therefore, bond angle decreases. Got it? That I will explain now on the valence shell electron pair repulsion theory in detail. Okay. Right. This is about lastly for hybridization. This completes hybridization of S and P molecules. SP, SP2, SP3. In SP3, one all bonding pair, methane as example. And now these are two examples where 3 bond pair, 1 lone pair, SP3 hybridization. And here 2 bond pair, 2 lone pairs, one also here. See, SP3 only, but 2 lone pair, 2 bond pair. Okay? Right. Now coming to next, d orbital hybridization. D orbital hybridization. 2 examples. I told you d orbital, generally DSP2 square planar, SP3D, that is trigonal, pyramidal, bipyramidal. Okay, and SP3D2, that is octahedral. Right? First, in the beginning only I told you, and SP3D3, generally it is called pentagonal bipyramidal. That is I epsilon. Once again, I will explain. SP2D or DSP, try to memorize. Okay, SP3D or DSP3, SP3D2 or D2SP3. Actually, come to know when you write SP3 and D2SP3. They are called inner orbital and outer orbital complexes. When you study D block elements in second year, that will come to know for that. Now this time, just remember this much, more than enough. Okay, SP3D3 or D3SP3. Got it? This is square planar. Remember, square planar. Tetrahedral or square planar. Tetrahedral if it is SP3 and if B inverse it is square planar, right? And here SP3D, I told you trigonal bipyramidal, and this one octahedral. Okay, and this one I told you that is pentagonal bipyramidal. These are fixed geometrical shape. If they are all bonding pair of electrons, all are bonding pair of electrons. Okay. Here the example square planar can be example, best example XeF4. And here the best example for this one PCl5, phosphorus pentachloride, and octahedral SF6 sulfur hexafluoride. Okay, and even this one IF7, one best example. Very good. We are having a generally hybridization involving even D. Along with S and P, the D, these are the four varieties. Square planar, DSP2. Trigonal bipyramidal, DSP3. Octahedral, D2SP3. Pentagonal bipyramidal, D3SP3. Or SP2D, SP3D, SP3D2, SP3D3. What are the fixed bond angles here? I told you for SP 180, right? Linear shape. SP2 trigonal bipyramidal 120. SP3 tetrahedral 109.28 or 109.50. Like this here, DSP2 square planar, all bond angles 90 degree on the four bond angles. PCL5 SP3D here 3 axial, 2 that is I told you 3 equatorial, 2 axial. All equatorial bonds 120 and axial bonds 90 degree. Got it? And SF6, what it is? SF6 octahedral, all 6 bonds they are 90 degree, right? 90 degree to each other. And IF7, that is pentagonal bipyramidal, here 6 bonds are 90 and 1 is 72. 72. Very, very important for CET, right? That's about the first geometry for d orbital hybridization. Please just remember these are the best classical examples. Okay. Coming to next, here we are studying only this one. These two, PCL5 and SF6. They have given for your theory centers: sulfur hexafluoride and phosphorus pentachloride. Let us write formation of PCL5, phosphorus pentachloride, using sp3d hybridization. That means in sp3d hybridization, 1s orbital, 3p orbital, even 1d orbital. They combine to form how much? 5 sp3d hybrid orbital having trigonal bipyramidal structure. Remember. See, because the d orbitals they are highly complicated. That's why we cannot give this combination. 1s, right? 3p means px, py, right? pz, and 1d. That's the means. They are double. Then x square, y square, that we know perfectly, right? When they combine, what they give? Trigonal bipyramidal. Resultant will be like this: 3 bonds and 2 bonds like that. Okay. This is called trigonal bipyramidal structures. Sorry. Okay, right. That means if center at A, this is B, this is B, this is the B atom, B atom, B atom. Trigonal bipyramidal structure. All bonding pyramid. These two are 90 degree and these are equatorial with 120 degree. Got it? These are equal ones and these are unequal. These have more repulsion than these equatorial ones. That I will explain you using PCL5 as example. Okay. Now coming to the formation of PCL5. Now central atom here is possible because phosphorus is less electronegative than fluorine. Already I told you phosphorus 15 atomic number. You write here neon 3s2 3p3. See 15 group element. 3s2, got it? 3p3, px, py. But see here, how many atoms are there? 5 atoms. Whether 5 atoms is there, 5 half-filled orbitals are here? No. So therefore, when 5 chlorine atoms try to combine with phosphorus, 3s electron get excited to where? 3p is already half-filled. Go to next. What? 3s, 3p, okay, then it is 3b orbitals. Got it? Therefore, this is the ground state electronic configuration. Ground state this is. Next one, excited state. Excited state. This is ground state electronic configuration, short form. excited state electronic configuration of the phosphorus. What it will be? Neon. Okay. 3s1. Got it. Now 3b3. 3bx1, 3b1, 3b. And next it will go to next one. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 3d1. Got it? Here d1. Now this is 5 half-filled orbitals. Okay. Now they are ready for hybridization. That means 3x, 3b3, 3b1 orbitals in excited state. Now they will overlap with what? Chlorine atom. One chlorine atom only atomic number 17, right? Be very clear. It is also having neon 3s2, 3b5. Where it is having unpaired electrons, students. Very simple. 1, 2, 3. No need to write here. Just for your understanding purpose, writing here. 3px1, 3p1, 3pz1, 3pz2, 3px2, 3pz2. Now this is unpaired. How many such chloride atoms are there? कितना है क्लोरीन एटम? 5 है. तो 5 से 3pz, 3pz1 half filled orbitals of 3pz they will overlap. Half filled orbitals of 3s, 3p, 3pz and make a dsp3 hybridization. Got it? What is the valency of phosphorus? 5. Therefore, according to pentavalency, 3s electron get excited to not 3p, 3d1 because 3p is only half filled. Got it? Okay. Therefore, hybridized state, hybridized state electronic configuration, hybridized state EC, electronic configuration of phosphorus. Okay, see here. Neon. Now see 3s2, right? 3px2, 3py2. 3p. Got it? Now these electrons, see what you are observing from color and distance, right? Sorry. See this one, 3p, 3p6. Okay, now next 1, 2, 3, 4, 5 because there are 5 orbitals. 3d. See, this is how. That means see. What are involved? 1, yes, 3p, sp3d and 1d. Therefore, sp3d hybridization. Okay. For sp3 hybridization, just not to do what it should be trigonal bipiramidal. Definitely trigonal bipiramidal. See, these are very simple. They are not like that of sp2 and sp. Right? These are simple like sp3. Right now, write the phosphorus. Okay. Now, according to geometry, what I will do? See, 1 above. 1, 2 axial force. Okay. So both are having see the d orbitals are double tangential. That's why directly can go for say orbital overlap picture. Not necessary here because d orbitals are double. Okay, 2 axial. Got it. And 3. That's important. Another 3. On the same side, okay, having the equatorial force, right? So, see, now you can see, is that called equatorial force? Equatorial force on the 1, 2, 3. They are making quadrangle 120 and these are called above and below axial force. See, axial bonds are longer than equatorial bonds, and here 3 equatorial bonds. Okay, 3 equatorial bonds will make a bond angle 120. Okay, and the 2, that is axial bonds will make a bond angle 90 degree. They are perpendicular to each other. Lamba kona tilukadadaru. Okay, right angle. So what is the structure? Trigonal bipyramidal structure. Remember, trigonal bipyramidal structure. Alright, that's about very important information of PCL. See, 1, 2, 3, please, that is 2 marks, and showing that diagram carries 1 marks along with bond angle and trigonal bipyramidal. Shape compulsorily. Axial bonds suffer more repulsion than these equatorial bonds, and they are longer. Due to that's only repulsion between axial bonds and these equatorial bonds. Okay. Now it is the bonds, that means it is highly reactive. It is highly reactive in the reaction. PCl5 is reactive in nature. Why? Because of this axial bonds. Very important for CET purpose. This point to be noted. And bond angle, remember, hybridization trigonal bipyramidal. Definite geometry. All are bonding pair only. 5 bonding pair out of 3 axial and 2 axial and 3 equatorial. Remember, equatorial exactly equal bond lengths, and axial no, they are longer than this equatorial bonds. Right? This is formation of phosphorus pentafluoride. So now students, I come to next another formation of SF6 sulfur hexafluoride involving B2sp3 hybridization. The same day, there is also no any change. Okay. Now coming to B2sp3, formation of sulfur hexafluoride. Central atom sulfur, atomic number 60. 1s2, sorry, directly can get neon. Okay, 3s2, 3p4. Right? 3s2 in ground state electronic configuration. 3s2, 3p4, 1, 2, 3. 3px1, 3py1, 3pz1, 3px2. This is a ground state electronic configuration. Right? Ground state EC. Now there are 6 fluorine atoms. When 6 fluorine atoms try to combine with sulfur to make its hexavalency, 3s electron and 3p electron group, they get excited to d orbital. So excited state electronic configuration. Excited state EC, electronic configuration of sulfur. Okay, it is neon 3s1, okay, 3d3 and 3d2. 3s1, 3p3, 1, 2, 3 and 3d2. 1, 2, 3, 4, 5. 3d2. Okay, like this. 6. How many atoms are here? That must be 1, 2, 3, 4, 5, 6. There it was for pentavalent. Now this is hexavalent. Expanded octet, that is also expanded octet. 5 bond, 6 bond. See, this is the maximum covalency of phosphorus and as well as sulfur. Best examples. Now we will come to know why central atom have. It will try to have a maximum covalency, especially phosphorus and sulfur. Remember, still they are stable, even though there does not have an octet. Expanded octet, incomplete octet. Okay, they are the limitations of octet. Now you see, now one fluorine atom, you know, atomic number 9 is containing once again 1s2, 2s2, 2p5 and 1s2 paired 2s2 paired 2 2p5, 2px1, 2py1, 2pz1, 2px2, 2py2, right? Then 2pz1 according to Hund's rule. What you studied in atomic structure, that only I have explained. They are bicyclically then pairing states. Now these 2pz orbitals of the 6 fluorine atom, they will overlap here. 3s, 3px, 3py, 3pz, 3d1, 3d, forming D2sp3 hybridization. Very simple, right? Therefore, what will I write here? Hybridized state. Hybridized state EC means electronic configuration. Okay, therefore for sulfur it is see, neon, what is there? Now see, I will write all with the different colors. Okay, D5, 1, 2, 3, 4, 5. D2. These are ready for hybridization, right? Now see here. And this is from sulfur and this is from where? That fluorine. Here also. Fluorine. Okay? Got it? Now see. Fluorine. That means 3s2, got it? 3 bases and 3d. But see, here 1s, 3d, okay, and here 2d. What is the hybridization? sp3d. If it is sp3d2 hybridization, what would be the geometry, students? I told you octahedral. What is that octahedral geometry? I will show you now with the figure. Okay, both the one-dimensional and three-dimensional. It is very easy. If you are perfect in making rangoli, especially girl students will enjoy this. Let us see. Okay, so this is the concept. Okay, see, sulfur emits 6 electrons to account its hexavalency, and 6 chlorine atoms and combine sulfur. Here 3s, 3p both, they get excited to the next 3d level. That's why students I told you here electronic configuration, outer electronic configuration. This is according to KLMN rule, not according to Bow principle. I'm making joke, it's a Bow principle, right? So here, that's what here, 1, 2, 3, 4, 5, 6. Next after 3p it is 3p. Now all these are overlapped by 3pz. Oh sorry, 2pz half-filled orbitals. Okay, and they overlap form a octahedral geometry. What is that octahedral geometry? I will show you. See that octahedral geometry will be like this. Sulfur at the center. Okay. 1, 2, 3, 4, 5, 6. Like this. Right? Yes. Here 6. All sigma bond. They overlap actually to form a sigma bond. Okay. Like this. Got it? You can draw like this. That means these are all 90. They are also perpendicular 90 degree to each other. That's why I told you all 6 bonds are 90 degree in octahedral. This is one way, simple way. Or else I will show you 3-dimensional picture. Here, this is also right if you draw this, but 3-dimensional you can write. See, very interesting. Just I will show you. Draw a triangle. Another C inverted triangle, right? Inverted triangle. Then sulfur at the center, got it. Join these ends, right? Join these ends. This is 3-dimensional of what? Octahedral. Okay, now join these bonds. One chlorine here, another chlorine here, right? Another chlorine here, another chlorine here, another chlorine here, and lastly this chlorine. This is octahedral, okay, geometry of yes, sulfur hexafluoride. All bonding pair of electrons 90 degrees to each other. Okay, so that completes all hybridization process, students, involving dehybridization. What is meant for your theory purpose, right? Very simple. One inverted, one triangle, one inverted, then join all the ends and then join the ends. That's it. This is how this completes all hybridization process. I think you enjoyed this, but students, it seems to be easy when you hear, but practice make man perfect. Compulsory, whatever I am telling you this chapter in the same day, please revise it and read 3 times and compulsory write 1 time. Compulsory. Because see, this is a method of studying in college level. Whatever it may be, physics, chemistry, maths, biology. Compulsory, you should take your notes, read 3 times, write 1 times with rough books. Okay? Rough paper, take the pad, pen, read it, okay, and write it. It will take more time initially, but afterwards you will enjoy this. 1 time will take more time. But revise 3 times compulsory. Second, third. Okay, this is what trick is. Sorry, just I am giving you the tip for reading for college even, because generally you won't understand how to read because you are from high school, right? How high school study and college study will differ. That's why I am telling you, reading 3 times equal to 1 time writing. Compulsory. Practice make man perfect, especially chemistry and mathematics. Not only that, all subjects they need writing practice. Okay? Right. Now for CET purposes, students, I am telling you once again repeatedly, now onwards, now you are having CET books, MTG publication has been given to you, right? Whenever we explain some concept, go on, try to solve those questions on that only, because already solution is also given. It will be easier for you, right? This is my suggestion. Now, along with this MTG book, generally you are very tension, especially parents also. So this is my suggestion to parents as well as students for chemistry. First, whatever the notes we will provide you, go through, make perfect of that. Then this MTG book, okay. Then for NEET level and JEE mains and JEE advanced, you have to go stepwise. MTC will cover up to Karnataka CET and NEET, more than enough. Then if you want still higher, go for next Dinesh publication, stepwise I am telling you, Dinesh publication, right? After Dinesh publication, read Pradeep objectives, okay, Pradeep objectives, will go to JEE mains level. Now sir, still we need more higher, means Krishna objectives is one publication is there which is containing about more than 50,000 questions. You will be exposed to so many questions. That's why don't go to the bigger book first. Okay, first initially become perfect theory, then our MTG book, okay, up to NEET level more than enough, because 30 to 40% question out of generally 45 questions, okay, definitely will 50%, 20 questions will come from that book only. It's my experience, okay. But also see, Dinesh publication I am repeating, then Vasco's publication is also there. Then go for Pradeep objectives, and if you got very higher IIT level and advanced level, can go for Pradeep objectives, more than enough. And repeat, MTG publication, Dinesh publication, Vasco's publication, okay. Then what next one? Pradeep objectives and Krishna objectives, which are available in our library, right? You want and also try to have one personal copy of yours, which is easiest for you out of this, that you have to purchase, and 1 or 2 will be given from the library, because now because of this COVID-19 you are unable to cope up with the theory, as well as especially we are very much tense about CET. So don't worry, okay students, now it is not only for you, it is common for all the students, right? It has become a very threat for all the world, So we'll go with along with the world. We are not special, right? So don't worry, don't lose hope. Go on just reading day by day. Don't make it better. Got it? So this is the completion of hybridization process. And here from this hybridization for theory, I am repeating for sp hybridization, they will ask you beryllium chloride formation. Very rarely C2H2. For sp2, boron trichloride. Very rarely C2H4. And for sp3, definitely methane only. And very rarely this ammonia and water, what I explained you today. Okay? Right. Now with this, now I will tell you another very important theory. Now we understood Lewis-Landau theory, valence bond theory. Okay, two important theories along with a very important concept, the hybridization. Valence bond theory gives us chemical bond formation and the shapes of the polyatomic molecules. Lewis dot structure, just only you come to know how to write the structure, but it doesn't give anything about stability and shape of the molecule. Okay, that's why to overcome all this, and hybridization you just study geometry, fixed geometry, it's only for bonding pair. It is not applicable for non-bonding pair. So that's why to explain this, overcome these limitations, especially if lone pair are there, then how it affects the geometry, fixed geometry of the molecule. That can be explained very well by valence shell electron pair repulsion theory. Okay. So this VSEPR theory, very important. VSEPR theory, which stands for V for valence. Okay, valence means almost shell, electron, okay, pair, repulsion. Okay, theory. And this theory was given in the year 1940 by Sidgwick and Paul. They tried to explain formation of compounds without using the hybridization concept. See, we don't use here hybridization concept. Okay. Only how molecules are formed by the repulsive forces between bonding pair and non-bonding pair. I repeat, repulsive force of attraction. Repulsive forces between the lone pair and bond pair. Lone pair are also called non-bonding pair of electrons, which do not take part in hybridization or chemical bond formation. Just to example, you have studied already ammonia, water. The same we will study here, detailed examples. Right? So this was later modified by year 1957. Later it was modified. It was modified in the 1957 by Nyholm and Electron. Nyholm and Electron. They modified this in the year 1957. Right? That's why I say valence bond theory was given in the year 1927, but later it was modified by 1932 by Slater and Pauling. But in 1940 this theory was given after hybridization began. That's why I am not discuss this VSEPR theory until the completion of valence bond theory and hybridization. Now you can easily understand now this valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory means repulsion between the valence electron. If they take part in bond formation, they are called bonding pair. If they does not take part in bond formation, they are called non-bonding pair or lone pair. Okay? Right. Now, what are the postulates of this VSEPR theory? Let us see. What are the postulates? Postulates of the VSEPR theory. Postulates. Important for theory, okay, for 2 marks or 3 marks. First one, the shape of the molecule. Shape of the molecule depends on the number of valence shell electron pairs. Number of valence shell electron pairs. Whether they may be bonding or non-bonding. Remember, valence shell electron pairs. If they are taking part in bond formation, they are called bonding pair. If does not, they are called lone pair. Simple. Okay? Right. How, sir? If number of valence shell pairs under shape. Okay? Geometrical shape of the molecule. If number of electron pairs is 2. See this another important is VSEPR theory is applicable only for those covalent molecules which are having more than 2 resonance structure. It is applicable, otherwise no. Minimum 2. Okay? That's why see if there are number of valence electron pairs are 2, then shape of the molecule is linear shape. See how what could be the geometry? Just see how they are linear. A atom surrounded by B and B. Example can be beryllium chloride and mercury chloride. Best example. Okay. If there are 3, then it is triangular planar. Okay, triangular planar. Next like this. B. Best example. Boron dichloride, boron dibromide. If there are 4, okay, tetrahedron. If D orbital is involved, DsP2, that is square there, remember, right? See, tetrahedron means just we can arrange like this: A, B, and okay, like this. And here is 180. And here triangular planar. 120. And here 109.5 degrees. You can give best example methane. Okay? 4. If the number of valence electrons are 5, then see it is number of valence electrons are 5. That is a trigonal bipyramid. How is it? Central atom A surrounded by C. 1, 2, 3. They are in the same plane. One above and one below. D. Just now we already studied hybridization. I will do very easy. 3 bonds 120 and 2 bonds 9. 120, 1. Right? And again, give best example PCl5, phosphorus pentachloride. Just now we have studied. There are 6 pairs. Now it is octahedral shape. Then A atom. Then 1, 2, 3, 4, 5, 6. B. And here can give SSS. Right? So this is actually first important term that is possible. The shape of a molecule depends on number of valence and electron pair repulsion. Yes, if there are 2 pairs, linear, 3 pairs, triangular planar, 4 pairs, tetrahedral. Geometry will remain same. See, I am using the word geometry, not shape. Okay, but here we can tell here geometrical shape better. linear, triangular, tetrahedral, and these examples are to be studied. If it is 5 trigonal bipyramidal, 6 octahedral, like this 7 and pentagonal bipyramidal, same. So now it will make a very comparison between hybridization and this VSEPR theory. It will be very easy for you. And I will tell you later shortcut how to find the hybridization after this. Okay, because otherwise you will get confusion. That's what I want to tell you, shortcut to how to find the hybridization of central metal after this, because this will also help you very much. Once when you differentiate geometry and shape using this Greenspot theory, hybridization and this VSEPR, they can easily go for shortcut method, which will be helpful for your NEET purpose. Okay, that's why I am going stepwise. Don't make hurry, right? Please concentrate. But these have to practice. You have to keep in the mind. Linear means suddenly should come. Triangular, planar, this. Tetrahedral, this. And bond angle, and examples. Okay, triangular, triangular, SP, 3D hybridization. See, hybridization also will tell you here. Linear, SP. Triangular, planar, SP2. Tetrahedral, SP3. Here, say SP3D, same. And SP3D2, octahedral. SP3D3, 7 pairs are there. I have 7. Only one example is there. Very simple. Okay, that is pentagonal bipyramidal, which is very important. It has been asked one time in GE mains and even GE advanced also. Okay. Right, so that's about first postulate. That means if number of valence of electron pairs are 2, linear, 3, triangular planar, 4, tetrahedral, 5, trigonal pyramidal, 6, octahedral, 7, pentagonal bipyramidal. This is the first important postulate of valence electron pair repulsion theory. Electron pair repulsion theory. Okay. Valence shell electron pairs. Then second, since electron pairs repel each other. Why? Because they are negative charges. They may be bonding pair or lone pair. They are electrons. Electrons are negatively charged. Like charges repel each other. Right? And third, very importantly, electron pairs. This is most important. Electron pairs try to move as far as possible apart. As far as possible apart in preferred direction. In a preferred direction in space. Preferred direction in space. Space means 3-dimensional region. It is 3D, x-axis, y-axis, z-axis. How? So as to minimize repulsion, very important. Minimize repulsion and maximize stability. Right? Maximize stability. Maximize stability so as to give definite geometry, definite geometrical shape. Okay, to the molecule. This is very important. And I told you this VSEPR theory totally depends on what? Totally depends on the repulsion force. The repulsive force, fourth one last name, the repulsive force. The repulsive force in electron pairs follows the order, very important order. That is lone pair is greater than lone That means, see, lone pair, if both are lone pair, repulsive force will be more. If one lone pair, one bond pair, slightly repulsive force decreases. If both are bonding pair, bond pair, then still the repulsive force becomes minimum, almost zero. But you have to remember this, right? More the LPs, more will be the minimizing repulsion and making arrangement very, what we call strain on the ring, minimize the bond angle, right? As the number of lone pair of electrons increases, bond angle decreases, right? Inversely proportional. See, if they ask you for theory, you can write these four. And another two are there, they are applicable, not necessary, right? That means this VSEPR theory is applicable only for those molecules if they have at least two to three resonance structures. Means definitely 2 to 3 lone pairs indirectly, right? Otherwise, if it is less than 2, it is not applicable. But these are more than enough. Okay? The shape of the molecule depends on what? Number of valence electron pairs. And these electron pairs, whether they may be bonding or non bonding, they repel each other because they are like charged. They are all negatively charged. And these electron pairs will try to move as far as apart possible. Not like anything zigzag manner, but in a preferred, systematic manner, preferred direction, preferred in the space. They will arrange, thereby minimizing repulsion, maximizing stability, and giving definite geometrical shape to the molecule. See here, geometry also you got, repulsion force is there, they are moving apart, and stability also. See how nice it is explained. Okay, that's why this. There is a lone pair, there is a distortion in the geometry. There is a lone pair, there is a distortion in the geometry. If all the electron pairs are bonding pair, they have definite geometrical shape, regular geometry. But if lone pair enters, then it will affect the geometrical shape. Regular geometry will affect. That's why the difference between geometry and shape you will come to know tomorrow. I will tell you with the table. Regular geometry will not be affected, but there is a distortion in the shape as well as bond angle, and even that I will tell you. One example already I told you, in ammonia, nitrogen is sp3, it should have tetrahedral structure, but whether it is having tetrahedral, no, it is having trigonal pyramidal. Why? Due to one lone pair. Got it? If all the bonding pair, it could also be given tetrahedral. Even in the model also explained that 2 lone pair, 2 bond pair. See, once again, see, bond angle 109.5 to 107, one lone pair. Here 2 lone pair, bond angle decreased from 109.5 to 104, total 4 degrees. Got it? So the lone pair will distort geometry. Distort means disturb, deviate from regular geometry. That we are going to study tomorrow. Six possibilities are there. I will tell you very clearly, because otherwise you will get confused today. Okay? But this is more than enough today. We will stop here. The valence shell electron pair repulsion. Why there is a need, sir? Because we have to understand this valence shell electron pair repulsion theory is given. Why? In order to study the shapes of the molecule. Remember, not geometry but shape. How shape changes if lone pair enters into structure of molecular formation of molecule. But Civic and Powell and this even Nylom and Gillespie, they never speak about hybridization. That means without the concept of hybridization, they explain this theory totally on repulsive force between three terms. That's only lone pair, bond pair. That's why this is you have to remember this important part that you are going to study tomorrow. Once again, if there is a distortion in geometry, what will be the effect of geometrical shape? Okay, once again I'll repeat. If there are 2 lone pairs, electron pairs, the total number of electron pair may be lone pair or bond pair. If the total number of electron pairs are 2, linear, 3, triangular planar, 4, tetrahedral, 5, trigonal bipyramidal, 6, octahedral, 7, pentagonal bipyramidal. If they are out of that, that's only we are going to study tomorrow, whether they are bonding, non-bonding. If they are bonding, regular geometry. If they are non-bonding, irregular geometry. That's only we are going to affect the shape and bond angle. Got it? So because this is very, very important for your second year for P block elements. One definite question, 100% question in the NEET. That's why you should understand basic here itself. Tomorrow we'll enjoy this theory with the anomalies. That's only deviating from regular to irregular geometry. That I will tell you tomorrow. So today it is enough. So have a nice day. Enjoy.